Okay, so this was the example that we were working on from section 6.2 in our last class, and we didn't complete the example, but we got pretty far through it. So what we did was we have a differential equation, and we want to find two power series solutions for this differential equation about the ordinary point x equals 0. And what I'll do is I'll just take you a quick review of what we did. Of course, we let y equal the power series from n equals 0 to infinity of Cn times x to the nth power. And then we took the derivative. We took the derivative of that power series and wrote it in a nice form. Okay. And then we took the derivative of the derivative. We took the derivative of the power series for the derivative right here. And when we were, reducing things, we got it in this nice form. And then we substituted these expressions, the power series expressions, for the second derivative, the first derivative, and y into the differential equation. Okay, and then what we had to do was we had to, of course, we have these functions in front of the power series, so we had to distribute the functions through the power series, okay, which we did. We distributed the power series through the functions through the power series. You know, we did distributive property, and then in the end, well, not the end, but then when we did that, after we distributed those coefficient functions in front of the power series, distributed them through the power series, we ended up with an equation which had four power series in it, four power series. And of course, we want all of the powers x to the, we have all these different powers, x to the nth power, x to the n minus 2 power, x to the nth power, x to the nth power. We want them all to have the same power, so we let k equals, we made a change of index, and we did that for the four power series. And then we just, worked through the math here. And we got up to this step here.
Yeah, right here.
Right here. And then, based on the fact that the left side equals the right side of this equation, that meant that, of course, the 6 times C3 times X term, well, that has to equal 0 for all X values. So that means C3 would equal 0. Similarly, the power series here, okay, the power series, well, in that also, I want to say this the right way, for that to equal 0 for all X values, we need the coefficients of the terms in the power series, and these are hold on here, let me see. Yeah, I'm getting kind of used to this new thing here also. Yeah, these are the coefficients of the power series. They all have to equal 0. Okay, and so that was this statement here. So we had these two equations. And then also, we have what's left is 2C2 minus C sub 0. That has to equal 0. And so there we go. And so now what we wanted to do was this recursion formula here, k squared minus 1 times ck plus k plus 2 times k plus 1 times ck plus 2 equals 0. We want to solve for ck plus 2. And it turns out that c sub k plus 2 then is equal to 1 to the 1 minus k over k plus 2 times c sub k. And so now we have, we know something about our coefficients. We know something about them, but what we have to do now, of course, is, again, the problem said find two power series solutions to the differential equation. So, I mean, basically what we're working with now is this. This is what we're working with. C3 equals 0. 2 times C2 minus C sub 0 equals 0. And then C sub k plus 2 equals 1 minus k over k plus 2 times ck. 4, I want to be a little bit, let me be very clear on this. That's 4 k equals 2, 3, 4, and so forth. It's a recursive formula, or an iterative formula. So, like for instance, you could find, like for this iterative formula, okay, what's the lowest, what's the lowest C value that you can find something about?
C4.
C4, that's right. That's right, Justin, because when k is 2, when k is 2, that's the smallest value of k. And so C sub k plus 2 would be C sub 4. And then you could find information about C sub 5, C sub 6, and so forth. Okay, does that, are there any questions on that? Are there any general, let me just, I mean, it looks okay, but I just want to write it a little bit more neatly here. Matthew's good, okay, good. So again, C sub k plus 2 is equal to that formula, but only when k is 2, 3, 4, and after. So if we put in k equals 2 in here for k, the smallest value would be C, smallest coefficient would be C sub 4, or the earliest coefficient. The next coefficient would be C sub 5. That would be when k equals 3, because 3 plus 2 equals 5. Zachary, how do we know k can't start at, the reason we know k begins at 2 is because of this right here. The series for these coefficients, and that's where we get the formula from, begins at k equals 2. That's how we know. Okay? So what we have to do is the starting what coefficient, like C sub 2, if we're looking to find C sub 4, we have to put in a value for C sub 2. Okay, that's what C sub k would be. So we have to actually put in a value. So in order to find the value for C sub 2, well, C sub 2, 2 times C sub 2 minus C sub 0 equals 0. So I can solve that for C sub 2. Okay, I mean, this just means then that C sub 2 is equal to C sub 0 over 2. Well, that means then I got to put in a value for C sub 0. You know, I got to get the ball rolling. I got to put in a value for C sub 0. Okay, got to put in a value for C sub 0. And incidentally, I'm also going to need a value for C sub 1. I got to have some value because I'm not going to get it from this formula, and I'm not going to get a value for C sub 1 from this formula.
So where do
So
we get it
what
from?
we have, I'm sorry?
Sorry, you were going on. I'm sorry.
Yeah, so what we have to do is we have to choose values for C sub 0 and C sub 1. That's what we're going to do. And the way this works is, well, there are a lot of values you could choose for C sub 0 and C sub 1, right? I mean, we're choosing values, and there's a lot of infinite values, right? But what you're going to do is you're going to let C sub 0 equals 1, and you're going to let C sub 1 equals 0. And this is standard in WebAssign for your section 6.2 exercises that actually are posted now. There's some due on Sunday, some due on Tuesday. You can randomly, theoretically, you could randomly assign values for C sub 0 and C sub 1, but you're not going to do that because WebAssign is going to give specific power series solutions. Oh, what would those go with? One of the power series solutions will go with letting C sub 0 equals 1 and C sub 1 equals 0, like in this case. And then the other power series solution is going to go with letting C sub 1 equals 0 and C sub 0 equals 0. And that's standard, okay? That's standard. The reason they do this is because, well, they just need to pick values. Okay. So now if C sub 0 equals 1, I mean, let's see now. Okay, so to get the power series, I need to find values of the coefficients in the power series, right? And maybe if I can find the first 4 or 5 coefficients in the power series, that'll be enough so I can select the correct answer in WebAssign, like for multiple choice, okay? So C sub 0 equals 1.
Oh, so WebAssign will tell you, like, assume C sub 0 equals 0 or 1 and C sub 0 1
Yeah,
equals
it won't
half.
tell you. It won't tell you, but
Wait.
that's why I'm telling you. That's a good question, Matthew. Yeah, it won't tell you, but I'm telling you that's what they do. They let C sub 0 equal 1 and C sub 1 equals 0. Because those are the easiest values to pick. That's why.
Would you end up getting the same general formula?
The power series look nice. Question, Antonio?
Yeah, would you end up getting the same general formula, like at the end, no matter what value?
That you would. Well, the power series would look different based on what your starting values are for C sub 0 and C sub 1. But in the end, the general solution would effectively be the same.
Okay.
All right, good question. So, okay, C sub 0 equals 1, C sub 1 equals 0. We know that 2C2 minus 1 is equal to 0, therefore C2 is equal to a half. Well, we from the previous page, we knew that, hold on here. Hold on. From the previous page here, I'll come back to this. We knew that 2 times C2 minus C sub 0 was equal to 0. We knew that. But now we're letting C sub 0 equals 1. So that means then that 2C2 minus 1 equals 0. Hence, C2 is a half. So, all right, we got 3 coefficients now. 3 coefficients. C sub 3, we know that equals 0. Now we have 4 coefficients of the power series. C sub 4 is when k equals 2, because 2 plus 2 is 4. So I'm going to put, hold on here, I'm going to put k equals 2 in the formula. Okay, and that's what I do. I put k equals 2 in the formula here. right here,
So
and right here.
if we can choose these C0 and C1 values arbitrarily, then why do we not just leave them as C sub 0 and C sub 1? I mean, maybe it's a little nicer to write out, but I don't know.
Well, that's a good point. The thing is, without if it's like, remember in like a Maclaurin series. Maclaurin series, how do you find the coefficients of a power series, of a Maclaurin series? The formula is the nth derivative of the function evaluated at 0 divided by n factorial. That formula is used to get the coefficients of a Maclaurin series. You see, the series isn't useful unless we can use it to compute things. And so we want to get values for those coefficients. But in the end, let's say you were solving an initial value problem, and let's say that my coefficients were different than your coefficients because we started off with a different values for our beginning constants. In the end, we would get the same solution for our initial value problem. It doesn't matter really what coefficients you choose. It's just that WebAssign, these problems, are going to be, a lot of them are multiple choice, where you actually select. They'll give you 5 choices with power series, and you got to pick the right one. Well, by default, they're letting C sub 0 equal 1 and C sub 1 equal 0, like for a problem like this. That's all. That's all. C sub 4 is equal, good question. C sub 4 is equal to -1/8, because remember, C sub 2 is a half, and a half times a -4 is a -1/8. C sub 5, well, there K equals 3, right? Because C sub 3 plus 2, that's 5. 3 plus 2 is 5, and you're going to get -2/5 times C sub 3, which is 0. And you start seeing a pattern here. What are the odd terms of? Well, it's clear. I went out to C sub 6 and got a 16th. This is the solution. This is one solution, one power series solution. So one power series solution is right here. And you see what we did here. We put in, like this here is C sub 0. C sub 0, C sub 1 is 0. That goes in front of the x. C sub 2 is a half. That goes in front of the x squared. C sub 3 is 0. That goes in front of x cubed. C sub 4 is -1/8. That goes in front of x to the 4th, and so forth. So do you see how we constructed that? And the interval of convergence, by the way, for that power series can be shown to be the absolute value of x is less than 1. Okay, you would just use what you would do is you would get a general formula. This isn't asked in the 6.2 assignment, but you would get a general. You could figure out the general power series formula for this power series here, and then use the ratio test on it to determine the interval of convergence. Test the endpoints, all that good stuff, and you'll be good. You'll be good. Now, are there any questions so far? All right. Well, then let's go ahead. Then, are we ready to go to the next page? Okay, Matthew is good. Andrea is excellent. Okay, well, now on the next page, to get the other power series solution, we let C sub 0 equals 0 and C sub 1 equals 1. And then we go through the same process again, and we evaluate the coefficients. So turns out that for this time, all the coefficients are going to equal 0 except C1 equals 1. And so the second solution, you know, what it would be y equals, right, 0 plus 1 times x plus 0 times x squared. This is the second power series solution.
Why not have C sub 1 and C sub 0 both equal 1 here? Like, is there any particular reason we chose?
Here, you mean here?
Yeah, like in this example. Or for this second solution, yeah.
So second solution, we have to put in our we got to put in our beginning values for those first two coefficients. And, you know, we want to keep our power series simple. For the first power series, we let C sub 1 equals 0 and C sub 0 equals 1. Sorry, we let for the first power series, we let C sub 1 equals 1 and C sub 0 equals 0. Why don't we just switch it this time? Let C sub 0 equals 0 and C sub 1 equals 1. Keep it simple. That's all they're doing. And if you do that, you get this, then this is your second power series right here. But what does that just equal to? That equals y equals x. Okay, let me give you a moment to copy that. Let me know if you have any questions.
So if we didn't just flip them, would we not get the right answer? Like,
you would not see the answer in the multiple choice, in the choices of answers. You would not see your answer. That's correct.
No, I mean, like, so say we did
in WebAssign.
Yeah, no, I know we're just doing the 0 and 1 for WebAssign, but what if it was like 2 and 3? Would we have to do 3 and 2, or like does it just not matter?
That'll never happen. That'll never happen.
What do you mean?
It'll never happen in the homework.
Well, no, I'm just saying in general.
You could pick anything. You could pick anything for C sub 0 and C sub 1. In theory, you could pick anything. Because you're getting a general solution. The solution's not unique until you put in an initial value. Or two, I should say, you know, an initial condition, your initial conditions. But like, let's say, Antonio, you use different, you know, C sub 0 and C sub 1. Let's say you let C sub 0 equals 2 and C sub 1 equals 3. Okay, you're going to get different power series solutions, but you still have those and the coefficients will be different, all that. But when you put in your initial conditions, when you solve for the coefficients, it'll give you a unique power series that will equal your solution. Your final solution will be equal to mine, to the initial value problem. It doesn't. The coefficients are just. It's like a general solution. So the coefficients, your coefficients could be different than my coefficients. It's okay. Both are correct. But when we solve an initial value problem, then both our answers are going to end up being equal.
Right.
We're trying to determine a general solution.
Yeah, but like, so say this one, C sub 0 equals 0 and C sub 1 equals 1 gives you an answer of y equals x. That's almost no information. You know, like that's, I feel like if you just did that for both solutions, if you can really pick anything, you would just have two solutions of y equals x, and that doesn't really tell you anything.
I don't think you'd get that for the first one. I don't know if you would get that.
Can you go back one page for a second?
Sure.
Okay, sorry, I'm good. You can go for it.
You're very good questions today.
You can go forward, by the way.
Once you work with this enough, you're gonna you're going to have a comfort with it. But believe me, you're going to have a comfort. And some of these concerns you're having, you're going to say, oh, those weren't really concerns at all. You'll see. You'll see. You trust me, right? I'll take that as a yes.
Yeah, you can go forward now. I'm good on this page.
All right. Let me show you one thing here. So
okay, I see why.
What, now we have two power series solutions, right? So, just like in on the exam, when you want to find a general solution, you want to find a general solution to the differential equation. Okay, for our general solution here, our general solution is going to be equal to a C1. That's not a little C1. That's a big C1 times, let's see, what was the first power series was, hold on, maybe I'll use my stylus here. Hold on, this might work well with the stylus. Hold on. One moment. Hold on. All right, trying to get it right here. 1 minus, no, 1, sorry class, I'm doing the best I can here. 1 plus a half x squared minus 1/8 x to the 4th plus 1/16 x to the 6th minus, then dot, 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 keeps going, right? Plus a big C2 times x. That's the general solution to the differential equation, where instead of having functions, instead of having two functions, you have two power series. But sometimes, based on the power series you get, you might be able to figure out what's the function for that power series, if the power series is simple enough. Okay. So this is called a general power series solution. That's what we have.
Wait, is this our general power series solution, or is that on the next page?
It is. This is, well, we found two separate power series solutions. And once you have your two separate power series solutions, you can get the general solution to the differential equation by taking a linear combination of both of the power series that you found. It's that simple. The two power series form a fundamental set of solutions. Those two power series. They're independent, right? And linearly dependent. And tell you what, now let's look at another example here. Let's look at another example, okay? I'm going to stop the recording on this and go to a new example, all right? So let me stop the recording. We're done. So we've completed this example. We have finished it now, okay? We have finished this example.